today's tutorial, we will be talking about enumerations in Swift. The topics are enumeration syntax, declaration and assignment with enumerations, enumerations in Swift statements, associated values, raw values, and finally recursive enumerations. In Swift, enumeration is one way to create a new type. In its most basic form, an enumeration contains a set of values which share the same type, which is defined by the definition of our enumeration. As a simple example, let's consider the case when we are thinking about fruits. Example of cases which could be considered as fruits are apples, bananas, and oranges. So if we are thinking about enumerations in Swift, in this particular example, we can use fruit as being the name of the type which is defined by our enumeration. So fruit is going to be a new type. And then the so-called values or cases of this new enumeration type are apple, banana, and orange. As another example, let's consider the case that when we're thinking about colors, some cases that we could consider for color are blue, green, red, and yellow. Then in this particular case, when we are thinking about enumerations in Swift, we can take color to be the type of a new enumeration. And the values and cases which will take this type, in other words color, are blue, green, red, and yellow. The basic syntax used in Swift for enumerations is shown here. We start with the keyword enum, E-N-U-M, the name of the enumeration type. Then we have a set of curly brackets, and within those we list our cases. With each case we are associating a value. So value 1 here is associated with the first case, value 2 with the second case, and value n with the nth case. As I mentioned earlier, what appears here is going to be the name of the new type that we are defining using enum. Because this is going to be a new type, we follow the convention which is used in Swift, and we capitalize the first letter of the name. And it's a good practice to use a singular name here rather than a plural name. As an alternative to this syntax, we could list all our cases on one line and use the keyword case only once, as opposed to using it for each individual value. Let's go back to one of our previous examples, fruit. How would we show this as an enumeration type in Swift? This is the way it could be done. We start with the keyword enum as above, and the enum name is going to be fruit in this case, and the different cases would have three different values: apple, banana, and orange. Alternatively, if we want to list all of these on a single line, we can use this format like this. When we would like to declare a parameter to be of an enumeration type, and then assign a value to it, we can do it in a number of ways. One way is when we separately declare and assign. This is similar to all the previous cases that we discussed before for different types. Here we start with the keyword var or let, followed by the name of the parameter, then a colon, and after colon we mention the enumeration type. So this would be the case of declaration. Then to assign a value to this parameter, we use this format. We say that parameter is equal to the enumeration type followed by a dot and then the value of the enumeration, and that value is chosen from the list of values in the body of our enumeration definition. So if we wish that x to take the value which is equal to orange, we can do it like this. Or we can use a shorthand. If we already know what the enumeration type of the parameter is, we do not have to mention the enumeration type again. We can just use dot followed by the value of the enumeration. If we wish to simultaneously declare and assign, we can use a syntax like this. Again, the keyword var or let, followed by the name of the parameter, colon, then the type of the enumeration. This would be the declaration part, which is exactly the same as all the cases we've discussed before in the case of other types in the past. And then the assignment operator, followed by the type of the enumeration, dot, and then the value of the enumeration. Alternatively, as a shorthand, we can just drop the type of the enumeration when we do the assignment. Finally, we can do simultaneous declaration and assignment, but this time we infer the type. So this is an example that we can use. Var or let followed by x, then the assignment operator, then we continue by mentioning the name of the enumeration type, in this case fruit, followed by dot, and then the value of the enumeration. So here Swift, by looking at this, realizes that we are dealing with an enumeration type whose name is fruit, and the value of that is going to be orange. So the type is inferred here, so it knows that x is going to be also of type fruit, and the value which is assigned to x will be the value which is mentioned here in front of the dot. If we wish to reassign a new value to a parameter, we can follow this example. Again, let's take our simple example that we discussed earlier. Now, we can do the assignment here by any of the three ways I mentioned earlier. And then when we do the reassignment, we can either do it by mentioning both the name of the enumeration type and also the value. So we could say x is equal to fruit.apple. That would be a reassignment after we first make this assignment. Or because we already know that the type of x is the enumeration type fruit, we don't need to mention the name of the enumeration type when we are reassigning a value to x. We know already that x is of type fruit, so all that we need to mention is the value of the enumeration type, and that could be done by just using the shorthand that we saw earlier, dot followed by the new value that we wish to assign to x. We can also use switch statements in connection with enums in Swift. Take this example where we have an enum type called fruit with these 5 possible cases. Now we can declare a variable called myFruit to be of type fruit and then assign the value apple to it. Now the switch statement, which uses this parameter, can be something like this. We have the keyword switch followed by the name of the parameter. Then we say if our parameter, myFruit, has a value apple, do this. If it has a value banana, do this. Otherwise, do this thing. Notice that in order to access the value of the parameter, you have to use a dot followed by the value of that parameter. Without dot, we will see an error. The other thing to note is that, like all the other switch statements, the cases will have to be exhaustive. We either have to list all of these enum cases here. If we don't, we have to use default to make sure that the exhaustive nature of switch is preserved. Finally, make sure that the keyword case, which is used in the definition of an enum, is not confused with the keyword case, which is used in switch statements. These are 2 different things. If we have an enum definition like this, sometimes we may wish to associate some values, some additional values with the values of our enum. For instance, in this example, we might want to associate the color and the price of this pen and insert it as an additional information into our enum definition. In the case of the book, we might wish to enter the category of the book. And in the case of stapler here, we may not wish to add anything. So once we come up with the values that we would like to associate to these different cases, we can think of, okay, what would be the types, the Swift types that we would like to use to define these additional values. So in the case of the pen, we can think of the color to be of type string and price to be of type double. In the case of the book, we could think of the category to be of type string. Now, how can we include this information in our definition of enum? It can be done like this. We have the same format as before. The only thing that we add is that in front of each of the cases where we have additional information, we only place the types of the additional pieces of information that we would like to include. So in terms of pen, we include string and double. In the case of book, we insert string, and a stapler does not have any additional information. The important thing here is that we do not include any actual values here. These are just the types of the additional pieces of information that we put there. So when we have an enum definition like this, when we are dealing with declaration and assignment, we can do something like this. For instance, if we would like to have a variable called x1, which is of this type, then if you would like to assign the value pen to this parameter, we have to follow the same format as our definition. So inside the parentheses here, we will have to provide the actual values of these additional pieces of information. So in the case of pen, we have to provide a string. For color, we're using black here. And in the case of the second parameter, double, which was the price, we have to use a value of type double, 250 here. So here we are saying that the value of our parameter x1 is a pen, and it has associated values black and $2.50, which both match the formats that we used here in the definition of our value pen. If we print the value of x, we will see something like this: the name of the value followed by the actual parameters associated with that value. Once we make an assignment like this, we can reassign a new value to x1, and the new value has to be selected from the list of values in our enums definition. So in this case, I am reassigning x1 by a new value stapler. But stapler does not have any associated values, so we can just use it directly like this. We can use the inferred arrangement in this our last example, where we are saying x2 is a variable. The type of x2 is inferred by desk object here. Then the value of x2 is found by noticing what appears after dot, which is book fiction. Again, notice that whatever we put here has to follow the same format there. We're using the value book, but book has an associated value which is of type string, so we will have to mention a string within parentheses to make sure that the format of whatever we show here is the same as the format of our definition there. In other words, if we had used only dot book without the parentheses, this would cause an error. If we have a definition like this, which is the same as our last definition, And if we wish to use this in conjunction with a switch statement, how do we do it? So in the case of this example, we are defining a variable called x, which is of this type, desk object, and we are assigning this value to it. Now, if we wish to use x in a switch statement, we can use this example where we say that if x has a value pen with these two associated values, do something. If x has a value book with this associated value, do something else. And if x has a value stapler, do this thing. We have to use default here to make sure that the switch statement cases are exhaustive. The reason for that is these three cases will not cover all the possible cases that we might have. For instance, we could have the case when the value is pen and the associated value is blue, or the price is something else. So in order to make sure that that requirement is fulfilled, we have to use default here. Switches can be used to access the associated value of different cases of an enum. For instance, in this example, we could have an example like this, where we defined x to be a variable of type desk object, and desk object is defined here. And we assign to x a value which is equal to pen, and the associated value used are here. Now, if we decide to extract the values, the associated values, using a switch, we can do this. We use the keyword switch followed by the name of our parameter. Then we list all the possible cases: pen, book, stapler. Then within the parentheses here, we are mentioning two different parameter names. These are going to be temporary parameters which are only used within the body of this case. So if the value of x is pen, we declare a constant called color, and we assign a value to color which is equal to the first associated value of pen. Similarly, we assign to a new temporary parameter called price the second associated value of pen, which is 250. If, on the other hand, the value of x is equal to book, then we can extract the associated value of book, which is of type string, by using an arrangement like this, where within the parentheses we declare a temporary parameter called category, and the value which is assigned to that temporary parameter will be taken from the single associated value of case known as book here. In the case of stapler, as we do not have any associated values, we don't see the need to extract those values. If the temporary parameters that we are declaring within the parentheses are all constant or are all variables, then instead of mentioning the keyword let or var for individual temporary parameters, we can factor out let and put it outside like this, or factor out var and put it out. So when we have something like this, we are saying that all the temporary parameters within the parentheses appearing in front of our case, they're all constants. In this case, we only have one parameter, but if we had more parameters, this would have meant that all of these parameters are variables. In this particular case, we are saying category is a variable. Something to note here is that in the case of this example and the previous example, we are satisfying the exhaustive requirements for the switch statement, so we don't need to use a default case. But as a final example, let's consider this case where we are saying that if x has a value pen, if the second associated value of pen takes a value 250, we are only declaring one parameter here to extract the first associated value of pen. So we are not declaring two. But because we could have used many different values here for price, and we're not mentioning all those different possibilities in the list of our switch cases, we have to use a default case to make sure that all the combinations that we are not mentioning are covered. And in other words, the exhaustive requirement of switch is fulfilled. This brings us to the end of the first part of our tutorial on Swift's enumerations.